Hey everyone, welcome to Lesson 7. We're going to be talking about minds and machines, and more specifically about artificial intelligence and what passes for artificial intelligence these days, right? Which is large language models, right? There's also image generators, there's video generators, right? But they all work on a similar principle. And the question that we're going to be looking at today is how they map onto the distinction that is talked about in the Crash Course video. So if you haven't already watched that, they cover it really well and in a more comprehensive way than what I'm going to look at for this video. So if you have not watched that yet, I'd strongly recommend that. But here's the basic distinction, right? So before large language models like we're familiar with today, like ChatGPT, Copilot, and stuff like this, there was, artificial intelligence, right? We were truly trying to figure out, is it possible that a machine could think like a human being, right? And so, or was it perhaps more likely that machines could only simulate some kind of limited cognitive abilities, right? So, it's an interesting question, right? It's a really high bar to have a machine that truly thinks like a human, right? And the question is, right, ChatGPT can have some pretty sophisticated looking outputs, right? You can ask it questions and very quickly it can generate an answer, which gives the appearance of cognition. So is ChatGPT or similar large language models strong or weak AI? All right, so in order to understand this question a little bit more, we're going to have to look at how a large language model works, okay? Very basically, a large language model works on these three principles, right? First, data. A large language model takes an enormous amount of data, hundreds of gigabytes, far more than hundreds of gigabytes, maybe hundreds of terabytes worth of information, right? A truly enormous amount of text, and it trains itself on this data, right? What does that mean? It's going to take a sample text, right? From all of that data that it's taken, it's going to test itself, basically. So it's going to generate a prompt for itself, and then it's going to predict what the next word is. And it might assign different values for how likely the next word is going to be this rather than that. And then it guesses. It's going to make a guess. Then it compares that guess with the original document that it's trying to predict. If it got it right, good, it's on its way. If it got it wrong, then it's going to tell itself, something went wrong in my prediction there, and it's going to change a bunch of variables. And when I say a bunch of variables, I mean a bunch of variables. I mean millions, maybe even a billion variables it can change in its prediction patterns in order to try to figure out what that next word or next set of words is going to be, right? So we know then that a large language model is basically a big prediction machine. Kind of like your phone's autocorrect, like when you're texting someone and that next little word appears on that top bar and you can click it, and if you keep clicking it, it usually produces something pretty interesting. Well, that's kind of what a large language model is, except for the data, instead of just your text conversations, is enormous amounts of data, right? So this is kind of how they work. They are extraordinarily sophisticated guessing machines as to what word comes next. All right. This is important when we consider the strong versus weak AI distinction, right? Does AI, like a ChatGPT, really think? Well, at least from what we know about how they're trained, it seems like they don't, right? But this is difficult, right? Because one of the first tests to think about does how would we be able to know if something met the criterion of strong AI? Well, we should apply the Turing test, right? This was developed by Alan Turing, basically the father of modern computing, in the 1940s and 50s. And he developed the Turing test, which is basically, how do you tell if a machine can think? Well, you basically ask it, right? So the Turing test is supposed to be a person and a machine on the other end. You're supposed to have a conversation with that machine, and if the machine produces sophisticated enough outputs, then can it pass as a thinking thing? Well, if it seems like it's thinking, then maybe it's thinking, is the idea here, right? And for a long time, that was a pretty high bar, right? It's very difficult to produce human-sounding text in any kind of speed, with any kind of accuracy, right? But I think large language models might be able to pass a Turing test in the right situation, right? It's actually pretty amusing. If you ask ChatGPT, could you pass the Turing test, what does it say? But this might not be the end of the line, right? Searle's Chinese room thought experiment is, imagine we have two people. One of them speaks Chinese and the other one doesn't, right? So the question, the test here is, could someone give the appearance of understanding language without actually understanding it? Okay, so say the Chinese speaker first writes something down and sends it to the person without seeing them, through the door. That person, not understanding Chinese, has access to a lot of reference material, right? Say they have a whole bunch of dictionaries and they have instructions basically saying that if you receive this block of text, then you should send back this block of text, okay? And it seems like if they could do this fast enough, right, and the instructions were good enough, that you could quickly send responses back that appeared to be the response or the end product of thinking and understanding what's being said without ever having understood what was actually going on. Because your instructions told you what to send back, it's not necessary for you to understand what's being said for you to maintain a conversation, okay? And arguably, this is kind of what a large language model is doing, right? We know that it's trained on a huge amount of data, and that data becomes its own instructions, right? If I receive this or I see this kind of text, here's what's likely a good response to that based on this enormous amount of data that I've trained myself on. So Searle took this experiment to demonstrate that even a machine that passed the Turing test does not necessarily think like a human, right? We might think that in order to think like a human, we would need to understand what's being said, what's called the semantic content of the other person, or of the message that we're receiving, in order to be thinking and responding as a human being would. So this raises the question, when, if ever, should we trust the outputs of a large language model? Well, we can evaluate this on a couple of levels. On an intuitive level, right, what do we feel about certain questions when they're asked about us? Consider this, right? Say you were in a tough legal case, would you trust a large language model lawyer to represent you? If you were going through some challenges in your life, would you trust a large language model to provide you good life advice about what to do? Or if a large language model was asked to provide instructions to a caretaker to take care of someone that you love, would you trust its outputs, right? How you feel about those questions might give you an indication already about how much you really trust a large language model. Another interesting phenomenon that large language models engage with that might affect the way we think about their trustworthiness is their sycophancy, right? There's been significant excessive sycophancy concerns with ChatGPT recently, where you'll give it a thought or an idea and it will respond, "That's the greatest thought I've ever heard," right? Or "This is a brilliant, divinely inspired idea," and it'll go from there. So if we know that ChatGPT is going to be an enormous kiss ass, then do we trust its outputs more or less, right? And why is that? We might, on a rhetorical level, be more, we might want to hear that our ideas are, brilliant, but if we know it's going to be telling us that it's brilliant, is that an actual reason for trust, right? I think another interesting question here is, would you prefer if a large language model had more epistemic humility, right? What would it look like if you provided ChatGPT a prompt and it responded with, "Well, I'm just an advanced autocorrect, and so I don't know anything, but here's what I was trained to say," right? Would that actually be a better tool? Would that be a more helpful tool, a more socially responsible tool, etc.? So an interesting questions to think about, which might inspire some intuitions or some thoughts about how much you actually trust large language models. We can also test this on a more empirical level, right? We know how large language models work, how they are trained to provide data, and we know that based on their outputs, they hallucinate, right? What's called an AI hallucination. This is when experts are evaluating the outputs of ChatGPT, or even non-experts. We can pretty quickly tell it's just making stuff up, right? It will very confidently assert something is true that is definitely not true, right? And this would be what we expect if something was going on like what happens in Searle's Chinese room thought experiment, right? It doesn't understand what it's saying, right? It's merely taking a text input, and then it has a series of instructions, and it puts an output without ever thinking through what it's saying, right? That certainly seems a likely explanation of about what's going on with these AI hallucinations, right? So again, this is a well-documented phenomenon where based on its training data, it will say something very confidently that factually very easy to disprove, right? So given all of this, I think one last question that I'll leave with regarding trust is if large language models are supposed to be a tool, then what is its proper use, okay? And what do I mean by that? Well, almost all tools are going to be open to abuse, right? Take a microscope or a calculator, right? These are far less sophisticated tools, but even they have a potential of being abused and can produce false outputs, right? Because of this exact problem. These are, very weak AI, if we're even calling them AI. But what they do is that they take inputs. They have a series of calculations of logical functions in the case of a calculator, or it's just an instrument, like in the case of a microscope, where it's simply distorting or and amplifying the way that we already see things. These can still give false outputs if we don't know what the tool is doing, right? Say you're in an advanced math class and you don't know how to program or enter the math problem you want it to answer, right? And if you put in the wrong formula, right, it'll give you the wrong answer every time, right? Similarly with a microscope, right? If you're looking at something under a microscope and it appears really blurry, right, and you don't know that in order to use this tool you need to focus it, you might come away with the understanding that everything on the microscopic level is blurry. Like, that's just how it is. But obviously it's not, right? It's a misapplication of the tool. Okay, so what does this mean for education? Well, I think this is a much harder question, and one that I hope you'll join me in considering, right? And a note on it from my side as an educator, right? You may have noticed that the way that I grade things in this class is really kind of like a checkmark based system, right? Did the response do this, in fact, right? Why do I do this, right? A lot of other teachers will grade something based on their perceived quality of the response, right? Was this a good argument? Well, the reason why I don't do that is really for a number of reasons. The first is because I want, for the purpose of this class, to focus on participation, effort, and engagement with the course, right? Not necessarily polish or precision, right? I'd rather, learning kind of happen as a product, like as almost a byproduct of doing the work, but I don't always think it's the most fair thing for me to assess that learning directly, right? Because there's you could be understanding something very well and just not be able to communicate it very well, and so I think that picture gets complicated. Another reason is because I think this approach helps to shield you, the student, from my subjective biases as a teacher, right? And I think therefore it makes grading more equitable. Grading can be highly subjective, right? There are studies that show if you give a set of teachers, right, the same assignment to grade, give them the same instructions, but the assignment, like the grading criteria are based on quality or perceived mastery or competency or something like that, how those teachers will grade your assignment varies like 40 points, right? So it could either be a D paper or an A paper. And I just think that's a little bit silly, so I'm trying to appeal to more objective criteria here with grading. Um, Finally, I think my approach, reflects a deeper skepticism I have about the role of grading in higher education generally. I think it's really unclear to most people, from teachers all the way up to college deans as well as employers, what grades actually measure or what they're supposed to mean. So, for instance, are they supposed to measure effort or mastery or strategy or learning, right? Maybe this is what it's supposed to measure, right? But I suspect it mostly just measures privilege. So here's the thing, right? In this class, just because your assignment scored well doesn't necessarily mean it's a great argument, and that's okay. The goal with these assignments is not necessarily to produce professional grade philosophy papers or to produce the best arguments I've ever seen, right? But it's to practice those skills, to try to work out these things and often to fail at them. But I'd rather you fail in this course and receive feedback from me and improve it for the next time, so that when you apply it in the real world where it actually matters, right, that's when you're going to be applying it better. So that's kind of how I think about grading in this course. And where does a large language model fit into this? Well, if you've used a large language model on some of your assignments, then it's probably actually pretty good at meeting the meeting the check marks that I'm putting on assignments, right? That doesn't necessarily mean it's a good argument, right, or that it doesn't have flaws. But if ChatGPT has been a co-author for you, what I want you to consider is that serving the purpose of your learning in this class, right? Is it helping you grow or helping you to avoid growth? And this is really part of what I want you to be thinking about for the purposes of this short paper in this class, right? So here's the short paper prompt. What should count as morally acceptable use of AI in a college course? And does the answer change in a philosophy class focused on ethics and moral reasoning, right? Why or why not? I think that your answer to this is really going to depend, again, about your ethics and your principles that you hold yourself to. I think it's going to matter why you're taking a course. I think it's going to matter. It's going to matter on what kind of course it is. So I think there's a lot of things that you could put into this answer, and I'm really genuinely excited to learn from you, right, from the perspective of a student. How we should think about large language models in education going forward, right? This is an ongoing problem. Large language models were introduced right as I was leaving grad school, and so it didn't really factor into my education, but it's become an almost ubiquitous feature of education since I've become a teacher. So I'm really excited to hear what you have to say about this, and if you'd like to talk through it further to develop your ideas before putting them down in your paper, please do let me know. And check out those check boxes that I'll be looking for in the rubric that I've attached to this paper prompt. In any case, I'll catch you in the next lesson.